Hi folks, welcome to Lesson 3, the basics, the subnet mask. Now the subnet mask, its job is to help us separate the host and network portions of the IP address. So let's get started. So we're talking about IP version 4. Now I know a lot of you guys have heard of IP version 6 and oh well, why are we learning IP version 4? Well, the reason is obviously the internet's still running on IP version 4. Most businesses are running IP version 4, and the ones that have moved to IP version 6 already are probably running IP version 4 and 6, or they're converting, version IP6 at their border, and then they're running IP4 internally. So you're still going to see IP4 for at least the next 10 years. All right. So in IP4, every IP address has 32 bits, and we write it as a number dot a number dot a number dot a number. And each number is made up of 8 bits, and that's why your IP address, the numbers, can be anywhere from 0 to 255, because that's the total combinations of 8 bits in a binary digit. When we write it this way, we refer to that as dotted decimal format. So when my IP address is 192.168.15.5, each of those numbers is made up of 8 bits. So, all right, before you move any further, you need to be able to convert these numbers into binary. So pause the video right here and take this 192.168.12.84 and convert that into binary. And then you can move forward. But if you can't convert that into binary, you have questions about how to do that, you need to go back to the first video in the series. All right, so if you did convert it, it looked like this. So 192 converts into 11000000, and you get the idea. So 192.168.12.84 would convert to all of this in binary. Now, when you look at today's textbooks, this is how they show you how to subnet. They're converting the entire IP address into binary. And later on, I'm going to show you kind of a shortcut so you don't have to do that. But moving on. So when we see 192.168.12.84, that number is actually there to help us so that we can kind of see things easier. So that's dotted decimal format. But down on the bottom, this is what the computer sees. So when you type this in, the computer sees it all in binary. Remember, all communication on your computer happens in binary. We either have some electronic circuit or we have fiber optics. And with an electronic circuit, I can send a pulse of electricity or no pulse of electricity, a 1 or a 0. Or I can send a pulse of light or no pulse of light on fiber optic cable, which would be a 1 or a 0. So all communication gets stripped down into the very basics of binary 1s and 0s. All right, moving on. So there's always a shared portion of the address, and then there's a unique portion of the address. If my mailing address, if my house was at 1313 Mockingbird Lane, then the shared portion would be Mockingbird Lane, because obviously there would be other houses on my street, and we would all have the same street address, so we would share that portion. So that's like the network portion. Everybody in my network shares the same network portion. And then 1313 would be my unique house number. There could be other houses on Mockingbird Lane, but there can't be a second house that's 1313 because that's mine. That's unique to my house. So there's always a host portion that's unique and a network portion that's shared. Now, in our mailing addresses, the unique portion is first and then the shared portion is last. But in networking, the shared portion is first and the unique portion is last. So when you see this IP address here, can you tell just by looking at it what part is network and what part is host? Well, we really can't because there's nothing to distinguish that. So that's where the subnet mask comes in. You can't really have an IP address without a subnet mask. In the very, very early days of IP4, we used classes, and we'll talk about those in a minute. But we haven't used those in more than a decade. So the subnet mask helps us to easily see where the parts of the address separate. So the subnet mask is always all 1s followed by all 0s. There can never be a 0 followed by a 1. It's always all 1s and then all 0s. So the 1s show us the network portion and the 0s show us the host portion when you line them up. So if I look at it like this, now I've got my IP address here at the top and I have my subnet mask at the bottom. Well, now it's very easy to see Anything above a 1 is part of the network, so these first two sets are part of the network, and anything above a 0 is part of the host. So that's the subnet mask job. It's like the combination to a combination lock. An IP address without a subnet mask is useless. And that's why whenever you go to type one in, a subnet mask is always provided for you. It might not be the right one, you might have to fix it, but it's always provided for you. Alright, so your next question is, well, how do I figure out what my subnet mask is? Well, in the early days, they came up with a way to classify the different IP addresses. And we had 5 classes, A, B, C, D, and E. Now, for the CCNA or any kind of networking, we only deal with class A, B, and C. D is for multicast if you're doing like net meeting or something like that. And then E, I've always called that experimental. You know, the government reserves that. But the classes, what they did was they said, hey, we're going to take the very first number of the IP address. And if it's 0 through 127, it's going to get a default subnet mask of 255. So any Class A IP address has to have at least a 255 subnet mask. And then in a Class B, if the first number of the IP address is 128 through 191, it has to have at least 2 255s. And if the first number is 192 through 223, it has to have at least 3 255s. So that's how they came up with the classes. They said, hey, we're going to make these classes, we're going to break it down like this, and then they're going to get a default subnet mask. So we always start with the default subnet mask. Now, if you ever look at other charts, or sometimes in your book, they'll say the Class A IP address is 1 through 126, and that's not really accurate. And I'll show you why here in a second. But first, see if you can tell what class these are. So I got 12.15.200.14. So what class is that? Remember, we're only looking at this first number. Where does this first number fit in? So I got 12. Well, 12 fits in between 0 and 127, so it must be a Class A IP address, and it would have this default subnet mask. Alright, so now I got 200.15.21.4. So all you have to look at is the first number, 200. So the 200 tells you the class. Well, 200 fits in here between 192 and 223, so that's a Class C address. And then I have 124. Blah, 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 blah. Remember, we only look at the first number to identify the class. So 124 fits in here, so it's a Class A. So it's as easy as that. You just look at the very first number and decide and find where it falls. Is it in this range, or this range, and then you apply the default subnet mask. Now, jumping back to this, why do other charts always show you 1 through 126? Well, they do that because 0 is reserved through the Internet Association, and 127 is reserved for loopback addresses. So neither of them can be used on the Internet. So they typically show you 1 through 126. But, truthfully, a Class A is 0 through 127 because the reason how they pick these different address ranges, or these numbers, 0 through 127, a Class A, the binary, so the binary bytes, or I'm sorry, the binary bits, the very first bit is a 0. So if I took 0 as the first bit and then added all ones after that, so 0 and then 7 ones, 127 would be my number. And if I had 0 through all zeros, then 0 would be my number. So a Class A IP address can be anything from 0 to 127 because it's the total possible combinations of only using the last 7 bits. So let me show you what I'm talking about real quick. So the very first binary bit has to be 0. And then after that, it can be anything. I can be 1, 1, 1, 1, 1, 1, 1. So that would be 127. Or I could have all zeros. And one more. So it's this through this, and that gives me 0 through 127. But the very first bit in the binary has to be 0. So that's how they did the classes. A Class B is 0, 1. And then a Class C, let me back that up. A Class B is 1, 0. Get rid of that. And then a Class C is 1, 1, 0. So a Class A IP address, and that's how they split this up. A lot of people think, well, did they just arbitrarily pick some numbers? Well, no, they said, hey, if the very first bit in the binary is 0, it's a Class A. If the first 2 bits are 1, 0, it's a Class B. If the first 3 bits are 1, 1, 0, it's a Class C. So, again, in just summary, a Class A is all the combinations of the last 7 bits, 0 through 127. And then a class B is all the combinations of the last 6 bits, assuming that the first 2 of the 8 are 1, 0. And then a class C, the first 3 bits are 1, 1, 0. Now, here's a little chart to kind of show you. You know, in a class A, the very first bit is a 0, and then these other 7 bits are for the network. And then in a class B, the first 2 bits are 1, 0, and then the next 14 are for the network. And then a class C has 1, 1, 0, and then the next 21 are for the network. And then there's class D and class E, but remember, you won't have to focus on those. Just worry about the class A, B, and C. Now, you won't have to memorize this or anything like this. They won't ask you any questions on the CCNA, but it's just good to know how did they pick the classes A, B, and C? Well, this is how they did. They just split the binary. All right, so then a class A has a default subnet mask of 255.0.0.0, and B is 255.255, and a class C is 255.255.255. So if I own a class A IP address, like I think General Electric owns 3.0.0.0, I could have 16 million computers on my network. Well, no, we would never want to have a network that big. Or I could split it into 100, or I could have 127 networks and 16 million hosts, that kind of thing. So you get the idea. So with a class B, I could have 65,000 hosts on my network. And with a class C, I could have 254 computers or hosts on my network. And then this gives you all the different possible combinations of networks you could do. So remember, 1 through 126 is typically what you see whenever they show you a class A. Just remember, in reality, it's 0 through 127 because you have to count 0 and you have to count 127, even though they're not really used on the internet. So if you wondered why this jumped from 126 to 128, that's why. And we'll talk about the 127 more in the next video. All right, then 128 to 191, and then 192 to 223, and you kind of get the idea. All right, and then if you check out the wiki for the Internet Association, you can kind of see the reserved. You know, 0000 is reserved for the Internet Association, the IANA or whatever. And then here are some of the Class A IP addresses. There's 3, 4, like 3 is General Electric. And then the military owns some. There's some other organizations that own some of these Class A addresses. But yeah, the Army Information Center owns 6.0. And RN owns 7.0. And the Department of Defense has 8.0. So it's just kind of neat. So just remember the classes A, B, and C. A is 0 through 127, and then 128 through 191, and then 192 to 223. All right. So if that's the case, what is the default subnet mask for these 3 numbers or these 3 IP addresses? Go ahead and pause the video now and write that down or figure that out. Make sure you're good with that. And I'll give you a second and I'll give you the answer. All right, this first one is .12, so we know that's a class A, so his default subnet mask would be 255.0.0.0. And this is 200, that would mean it's a class C, so his default subnet mask would be 255.255.255.0. And this is a class A because it's 124, which is between 0 and 128. I'm sorry, 0 and 127. So his subnet mask would be 255.0.0.0. So the default subnet mask is always our starting point. You should be able to look at an IP address and right away know what class it is and what the default subnet mask is. Now later on we're going to talk about some other ways where the subnet mask is not a 255 or a 0, but we'll get into that in the next video. But for now, just make sure you're good with this part here. All right, again, when IP4 first came out, we had classes and you had to buy an entire class of IP addresses. Well, that didn't last very long at all, and actually I don't think it ever went public. The problem was, if you looked at these total number of networks, if I sold all the Class A IP addresses, there would be 127. There's only 127 Class A IP addresses. There's only 16,000 combinations of the Class B, and there's 2 million combinations of Class C IP addresses. So if I add all those up, there's only 2 million IP or 2 million addresses I could give out if I was using an entire class. So they quickly realized, hey, this isn't going to work because obviously there's 7 billion people on the planet, and there's probably going to be more than 2 million networks in the world. So the way they fixed that was they stopped using classful addresses, and they came up with something called CIDR. And CIDR, or CIDR, depending on how you pronounce it, stands for Classless Internet Domain Routing. So by the time the internet went public, you didn't have to buy an entire class of address. So basically what we did was we started with the default subnet mask, And then we start changing the zeros into ones to divide it into smaller networks. And that way, instead of having to buy, like, obviously the smallest IP address we could have bought if it was classful was a Class C, and that would give me 254, hosts. Well, what if my business only needed one IP address to get out to the internet, or something smaller like that? What if I only had 50 people or something like that? Well, you get the idea. So let's say I purchased a whole Class C IP address, and I have 2 different locations for my business. So each location only has 50 employees. But a Class C address gives me 254 addresses. Well, each IP address typically costs a company $10 a month. Basically what happens is the Internet Association rents those to ISPs, and then ISPs rent those out to the users. So the going rate currently is about $10 a month. So if I had to buy an entire second IP or Class C IP address, it would cost me $2,500 a month. Well, if I have 254 I'm already paying for, and I only have 100 employees, 50 at each location, I don't need an entire, I don't need to buy a whole other class of addresses. I don't need to waste that $2,500 a month. So this is where CIDR comes in, or CIDR. Basically, I can split that 254 using CIDR, and that's what's called subnetting. So let me show you an example of that. So here's my big piece of the pie, and this pie will hold 254 pieces, or 254 usable IP addresses, because I bought the entire Class C. Well, I don't want to do the whole thing. I want to split that in half. So what I want to do is I want to split it in half so I can have 126 on one side and 126 on the other. Now you're probably looking, well, that's kind of weird, because now 126 and 126 is 252 and not 254. And actually, anytime you use CIDR, you're actually going to start losing addresses, and we'll explain that in the next video. So don't get too wrapped up in this now. I'm just trying to kind of show you why sometimes the subnet mask won't be 255.255.255.0, and there'll be some odd number in there. So let's say my Class C that I bought was 192.60.24.0/24. Now remember, the /24 is the subnet mask. That's the number of ones in the subnet mask. So if I convert everything to binary, it would look like this. So on the top I got 192.60.24.0, and my subnet mask has 24 ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So it would be 255.255.255.0. And this is a Class C, so everything works. So if I did that, I'd have one network of 254 users. But now I want to split that. So now what I do is I take this first 0 and change that into a 1. And now I can have 2 different networks. And that's what CIDR is. It's stealing the zeros and changing them into ones to give you more networks with less users. So think of it as I'm just splitting the pie and making the pie in the smaller and smaller pieces. All right, and we will get into that in the next lesson. So don't be scared if you have no idea what we just talked about there with the splitting thing. We will get into that next lesson. I just want to show you to kind of give you some background to why we no longer use the default subnet masks. Because up to this point you're thinking, well, the default subnet mask thing seems pretty easy. If the first IP address, if the first number in the IP address is this, then it's this. And that's where we start from, but nobody uses that anymore. That's just our starting point, and then after that we're going to see more and more difficult numbers. Alright, so moving on. So if this is my IP address, 192.168.12.84, and my subnet mask is 255.255.255.192, then I know I got some subnetting involved. Anytime you have a number in the subnet mask that's not 0 and not 255, then subnetting has occurred, or CIDR has occurred, however you want to say it. So because I have the number 192 in the subnet mask, that's not 0 and it's not 255. So now that signals to me that I have more than one network. So now I have to find out where the split is. So if I put those both together through decimal, I get all ones, all ones, all ones, then 2 ones. Then I have 6 zeros. Well, the split is here where the 1 and the 0 meet in the subnet mask. That's where the split is. Everything above a 1 is part of the network, and everything above a 0 is part of the host. So the network is shared with everybody, and the host portion is unique to only me. So again, that's what the subnet mask does. It shows us the combination so that we can figure out the lock. Can't have one without the other. You know, combination without the lock is no good, and a lock without the combination is no good. So when you color this, obviously it makes it a lot more clear. So now if I look and I want to split, hey, where's the network portion and where's the host portion? Well, I know this is host, this is network, this is network, this is network, and then the first two bits of the 64 are part of the network. So here I've got zero. Remember, this is 128, 64, 32, 16, 8, 4, 2, and 1. So this first 64 that has a 1 into it, that's part of the network. And then this and this are part of the host portion. So I would write it out as, hey, the network portion is 192.168.12.64. And then the host portion is all zeros. Is 010100, which only leaves me 20 because it's 4 and 16. So if you can't figure out where I'm getting this from, remember to convert this binary, we start at 1 and double it 7 times. So 1, 2, 4, 8, 16. So 4 and 16, that would give me the 20. And then 32, 64. And this one bit here gives me the 64. So that's where we make the split. So your books will show you this way. They'll have you do the entire thing in binary, and I always have you put the subnet mask at the bottom, and then where the 1 and the 0 meets in the subnet mask, that's where you draw a line, and everything to the left of that line is part of the network, and everything to the right of that line is part of the host. Alright, let's see if you can work out another example. So, same thing. Now I got 131.168.60.4, and my subnet mask is 255.255.224.0. Now, notice obviously in my subnet mask I have a number that's not 0 and not 255, so that means there's 1s and 0s in the same byte, which means that's where there's more than one network in there. So just remember, everything above a 1 is part of the network, and everything above a 0 is part of the host. So here, I know this entire piece here is part of the network because it's all 1s. So I know that 131 must be part of the network. And then here, this is all 1s. So I know that this part, 168, is part of the network. But here's where I got to get busy because that's where the 1 and the 0 meet. So remember, this is 128, 64, 32. So 131.168.32 would all be network, and then everything that's left would be host. And if I look at it like that, remember 131, and then 168, and then 128, 64, 32. And the 32 has a 1 on it, so that I have to count that. So that's where this 32 comes from. And then all that's left here is 28, and then 4. So 28.4 has to be the network portion. Now, that's the way your books will show you how to do that. They convert everything into binary, and then you got to work on it. I don't like that method because it takes too much time, and you only have to do one of the binary bits. Let me show you what I'm talking about. So here's a shortcut. So let's say my IP address is 172.16.4, and my subnet mask is a /22. So if I write that all out, all I really need to do is write the numbers and then find where the difference is. So let me show you what I'm talking about. So I need to write 172, and I do a space, just because it makes it easier for you guys to see. And then here is where I need to do something, because I know the subnet mask is 22 1s. So it's 255.255, and that would be 16 1s. 17, 18, 19, 20, 21, 22, 23, 24, and then the rest have to be zeros. So if I do it this way, then I only need to do binary for the two middle ones. Remember, anything above a 255 is always part of the network, and anything above a 0 is always part of the host. So if I look, I already know that the network side is going to be 172.16.something.0. And I know the host side is going to be 0.0.something.4. So anything above a 255 is automatically part of the network. Anything above a 0 is automatically part of the host. There is only ever one octet that you have to convert to binary. So you don't have to convert the entire thing. I just need to convert the 60 into binary, which would be 00111100, and then the whatever was left here, the 4 bits or 6 bits there, and just convert that. So then I just need to figure out what's the question mark. So if I line this all up all nice and neat, this example is kind of easy because the 1 and the 0 of the subnet mask matches here. So that means the entire 60 is here, and there's 0 there. So you don't have to convert the entire thing into binary. You just need to figure out what your subnet mask is, and then whatever number is not 255 and not 0, you know that's the octet that you're going to get busy in. And by the way, if we haven't mentioned this yet, each of these digits is referred to as an octet in IP4. So this is the first octet, second octet, third octet, fourth octet. And we call that octet because it's made up of 8 bits. So when I do it, I always put the IP address on top and the subnet mask on the bottom. And then any of the IP numbers that are above 255, I know that's going to be part of the network. And any part of the IP number that's above a 0, I know that has to be part of the host. So that way I don't have to convert the entire thing to binary like this, because that's obviously too much work for me, because I'm lazy. All right, now your turn. Take this 10.200.100.15, and the subnet mask is 255.240.0.0, and see if you can figure out what part is the network and what part is the host. Now, if you can't, it's not really any big deal, just as long as you kind of understand the theory of what we're doing here. Because what we're doing here with this host and network portion is not part of the CCNA. It's more to help your understanding, to understand what the subnet mask does, to understand the classes and the role, and that each IP address is actually 2 parts, and where we kind of go to get these parts from. So go ahead and pause the video now and see if you can figure this one out. Dun-dun-dun. All right, moving on. So hopefully you figured this out, and if you haven't, we know that there's a 255 above the first octet. So 10 has to be part of the network. And we know 0 and 15 are both above zeros, so those are part of the host. So I only needed to convert 200 and 240 into binary. Now here I converted the whole thing into binary, but you only needed to do this octet, the second octet, because everything else, you knew that this number here, the 10, was part of the network, and you knew that the 100 and the 15 were part of the host. So we only had to play with this number here and figure out where the split was. Well, 128 plus 64 plus 0 plus 0 is 192. So 10.192 is the network, and then 8.this.this is part of the host. So that's how you would figure that out. Now, if I would have done it, I would have done it like this. I'd have done 10.thebinary.100.15, and then 255.thebinary.0.0, and then I know anything above a 255 is part of the network, and anything above a 0 is part of the host. So there's only one place where you have to figure something out as. In this case, it's in the second octet, because that's where the 1 and the 0 meet of the subnet mask. All right, I'm going to give you one more. See if you can figure this one out. Go ahead and pause the video now. All right, assuming you either have this or you don't have it, that's what the solution looks like. All right, so final notes. To check your work, you can always add the 2 parts together and see if they equal the IP address. So if I added 152 plus 0, I'd get 152. If I added 64 plus 0, I would get 64. If I added 64 plus 37, I get the 101, and then 0 plus 146 would give me 146. And that would make the address. So put both your parts together, add them up, and see if they add up to the IP address. If they don't, then you've got an issue. All right, the subnet mask is sometimes given in what we call the slash notation. And I think we've already covered slash notation, but instead of writing the subnet mask out as 255.255.0.0, we just write the slash and then the number of ones in the subnet mask, because we know it's always all ones followed by all zeros. So as long as I know how many ones there are, then I know how many zeros there are, because there are always 32 bits in an IP address and 32 bits in a subnet mask. So because there's 32 bits, if I have a slash 18 slash notation subnet mask, I can just subtract that from 32 and know that I have 14 zeros. So I'm going to have 18 zeros followed by 14 zeros, because that adds up to 32. All right, since the subnet mask is always ones followed by zeros, there are only a few numbers that each digit can be. So remember, your subnet mask can be 255 and 0, but it can also be 128, 192, 224, 240, 248, 252, and 254. If I have one 1 in the subnet mask, it's 128. If I have 2 1s in the octet, it's 192. If I have 3 1s, it's 224. So again, if I have 1 1, it's 128. If I have 2 1s, it's 192. If I have 3 1s, it's 224. If I have 4 1s, it's 240. So these are the only numbers that your subnet mask can be. So the subnet mask can be 0, 255, or any of these 7 numbers. And those are the only numbers that can ever be in a subnet mask, because it's all ones followed by zeros. All right, and then here's a handy chart, that shows you all the different slash notation. Obviously, slash 8 is the smallest subnet mask you can have, and that would be an entire class A IP address. And then slash 30 is the largest subnet mask you can have, and that would only give you 2 usable hosts. And eventually we'll talk about where those are used. So again, if you don't understand exactly what we did and you can't separate the host and network portion, but you understand the thought process behind that, you understand what the subnet mask does, then you're good. And this lesson really is more of a primer for the next lesson when we actually get into subnetting, because subnetting is so big, I can't cover the whole thing in one video. So we start with this and then kind of move on. Now, with subnetting, we don't necessarily do the same thing that we just did here. We get a little bit more involved. But it's just, you're going to be using the subnet mask, so it's good to have an understanding of how the subnet mask is used, and then the slash notation, stuff like that. So that kind of wraps up this video. If you have any questions, post them in the comments below. Other than that, we'll see you in the next video.